I work for Edwards Vacuum. We make vacuum pumps. One of the uses of vacuum pumps is in the semiconductor industry using this stuff. That's silicon. So one of you, catch, can have that. That's a lump of silicon. And that's turned into high purity silicon wafers, which are then processed under vacuum. And I can simulate that here with this vacuum pump. So this is a vacuum pump, turn it on, and we've got a spark source there. Yep. So I reduce the pressure.
So with regards to
see? No spark, we've now got a plasma being generated in there. Okay, can't see it very well because it's light. There you go. That's treating the surface of the silicon. And what you do is you introduce gases into the chamber and use them to change the chemistry of the silicon. One of the gases is going to be nitrous oxide. Now nitrous oxide is the key ingredient in the propellant in whipped cream. So we take some whipped cream, almost out. That's it, the whipped cream. So those bubbles in there, in the cream, that's nitrous oxide. And nitrous oxide is a very potent global warming gas. So as we reduce the pressure, the volume of the bubbles increases. And we're extracting the nitrous oxide, which is just going into the atmosphere. So it doesn't matter here, but in a large amount, we would actually burn it with fuel to produce nitrogen, which is a safe gas. So, reduce the... There we are. So that's degassed whipped cream, or cream. Here you are, want some cream?
Good, thank you.
Right. What about marshmallows? Everybody likes marshmallows. Who wants a marshmallow? One? You want more than one? All right. I've got 2 marshmallows in here. Same story. They're foam because they contain bubbles. So, let's get the marshmallow, reduce the pressure, so they're now expanding. The bubbles inside are expanding, then eventually burst. There they go, collapse. We increase the pressure. Marshmallows with no bubbles in them. So somebody can have those. Thank you very much.
Thank you.
My name's Duncan Price. I work for Edwards Vacuum. We're based in Cleveland. and Edwards make vacuum pumps, and they're used in the semiconductor industry to make silicon chips. So here's a bit of silicon. Somebody can have that, catch. Good. So this is a wafer of pure silicon, and it's processed under vacuum to deposit various elements on the surface to modify its electrical properties to create a computer chip. I can demonstrate that here with this lump of silicon. I can apply a spark to it. That's at atmospheric pressure. So, spark. We're now in the vacuum, and you can see the colours changed. We've now got a plasma discharge there, and it's that nice violet colour because of the nitrogen and the residual nitrogen in there, and that's giving out, look, it's all gone spread all over the whole surface now. Quite nice. So in order to do some chemistry, we have to introduce gases in there to react with the surface of the silicon, one of which is nitrous oxide, and that's the propellant in whipped cream. Nitrous oxide is quite a potent global warming gas, much worse than carbon dioxide, so to release it directly into the atmosphere is very bad for the environment. So I've got some whipped cream here. And we're going to put it under vacuum. So as we reduce the pressure, the bubbles of nitrous oxide in there expand. And then they'll burst. There we go. So that is degassed whipped cream, or cream. Now vacuum pumps, Edwards vacuum pumps are also used in the steel making industry to remove gases from molten steel. There's some cream, somebody can have that. But much more popular are marshmallows. Marshmallows are similar, they're a foam, and that gives them a very nice texture in the mouth. I'm going to ruin that by taking the bubbles of gas out. As you can see, pressure and volume are related. You reduce the pressure, you increase the volume. There they go, up, bigger and bigger, and then they burst now. I increase the pressure. You are? Okay, my name is Duncan Price. I work for Edwards. We make vacuum pumps, and they're used in the semiconductor industry to make silicon chips. There's a lump of silicon in there. I'll give it away afterwards. Those are turned into these wafers, which are then processed under vacuum to produce the required chemistry to generate the required electrical properties within the chip. So I can demonstrate that here. That's some silicon, and it's under a vacuum chamber. So under normal pressure, there's a spark. I'll reduce the pressure.
What are you doing? Look at it. Oh, you want still watching this?
And now you can see there's that pinky glow.
It's pink.
And that's the plasma discharge. And with that we can do chemistry if we introduce appropriate gases into the chamber. So one of those gases is nitrous oxide, which is the propellant in whipped cream. So I've got some whipped cream, which contains bubbles of nitrous oxide. Now nitrous oxide is an oxidizing agent which is used to build up the dielectric layer of silicon dioxide on the surface of the chip. And we're going to remove that by putting it under vacuum. So those bubbles of nitrous oxide propellant that's in there will expand. This is cheap whipped cream. Those bubbles have now expanded and burst. And then we removed all the propellants from the whipped cream. So this is degassed whipped cream. Now they use vacuum pumps to make steel because when steel is being made, it contains gases. And molten steel, they put out all the gases by putting it under vacuum. Another demonstration is marshmallows. They're foamy, gives them a nice mouth texture. And again, we put them in the vacuum. So the pressure is decreasing, so the volume must be increasing. Here we go.
James.
What?
Right?
Colour better.
So the bubbles are burst.
That didn't happen with us.
That didn't happen with us. We're better.
Oh.
Look how small it goes.
Really small.
Look how small it is, James. They proper shrunk.
Here we are. Marshmallows with the bubbles taken out. Thank you. I'll pass those around.